right, so in chapter 8, we're going to learn a couple different formulas that can help us solve triangles. And the first one is the sine law. So as you notice first, we're no longer working with right angle triangles. So we're not using right angles anymore. But we are using acute triangles. And what this means is that all three angles are less than 90 degrees. So everything that we're going to be doing in grade 10, just be aware that we're always talking about acute triangles, meaning all three angles are less than 90 degrees. In grade 11, you'll start using obtuse triangles where one of them is larger. So it would be pulled out, so one of them would be larger like that. So we'd end up with an angle that is bigger than 90 degrees. That makes the math a little bit more complicated. So just be aware that that will be something that'll change next year, but this year we're always using acute triangles. Another thing we'll start off with is labeling them. So we always label and we talked about this a little bit, but we also talked about multiple ways to label our triangles. But here we are always going to call the angles with capital letters. And then we're using the same letter but lowercase to talk about the sides. And we always use the opposite side to the angle to use the same letter. So capital A is angle, and then the side across from it is lowercase a. Same with B, the one across from it is lowercase b. And same with C, lowercase c is the opposite side. So we always have an angle, which is a capital letter, opposite side, lowercase letter. So that's why we are always going to be labeling them from now on. So sine law, or sine ratio, or sine law, two ways to put it. If you take the length of the side and divide it by the sine of the opposite angle, and you make that a ratio, so divided by, and then you take the second angle and the second side, and the third angle and the third side, and you divide them A over sine A, B over sine B, C over sine C. That ratio will always be the same. And this is the sine law. So if you want to see it in action, I've got a little demonstration, which now has blocked me out of my account. See how fast I can get that. Oh, good. So if we look at sine over sine, or A over sine A, B over sine B, and C over sine C, again, angles are the capitals, and smaller case are the opposite sign. It's not written in here. But if we change the triangle in any way, those three numbers are always going to be the same. So they are always equal. If you take a side divided by the sine of its opposite angle, it will always be the same, all three of them. So that is the law. So that's pretty basic. If you want to see the proof of it, understand why this is true, you can go back and do the investigation in the textbook and look at the proof. I don't think you need to know the proof in order to understand that this is how it works. We just need to know where the things are. So just making sure that we understand that we are always using the opposite side to the angle, and using a sign for that angle. But all three of them will be equal. So we can use this to solve any acute triangle. So let's go straight into our examples. All right. So example 1, we are finding the side lengths using the sine law. So this is a word problem. A lock, so this is a river or a canal. A canal is a man-made river where they've dug out and let the water go through it. And they control that by using locks. Locks are really cool. I live on a river or canal with locks. And basically it'll open up the gates, they let the boat in, close up the gates, fill it with water, the boat rises up, and then they open the gates on the other side, and the boat goes out. So whenever there's an elevation, so they can basically bring a river uphill by using this lock system. So that's what a lock is in a canal. So we've got a bike path. That forms a 66-degree angle with the canal, with one lock of the canal. At a distance of 2.5 kilometers along the path, the angle separating this lock from the next lock is 52 degrees. And like I said, trigonometry is just trigonometry. It doesn't, like the physics that you learn in high school, always takes the easiest case. We don't talk about wind resistance. We don't talk about anything that's real life. Whereas trigonometry is still used the same way. You will still see surveyors out with their little cameras, taking angles, looking at things. It's still doing this math exactly the way it's been done for thousands of years. So this is an interesting part of math because it is totally real world, still used today. Still 100% the way you learn it in high school is the way you'd use it in real life. So now we've got a 52-degree angle. We're standing up here on the path. We're looking at both. We're taking our angles. And we want to know how long this section of the canal is. So our x, or what we're trying to find, is the length between the two locks. So we're trying to find the length of this side. So how far apart are the two locks? To the nearest tenth of a kilometer. And this we need to see people start understanding. On the last test it was a little bit difficult. People were not giving the answer in the way that it was asked. So we need to make sure we're doing that. So we're going to use the sine law. And the sine law is a side over the sine of its opposite angle. Just capital B. So we can label however we want. I've already got an X on there, so I'm going to call this angle capital X. Let's use A's and B's, so small a, angle A, we don't know. And angle B we do know, little b we do not. We're trying to find x. So we've got the angle x is 52 degrees. We've got, let's see, what do we know? Angle A is a mystery, but little a is 2.5. Angle B is 66. What side B, we don't know. Angle X is 52 degrees. and little x side x is what we're trying to find out. So we need to have pairs in order for this to work, and so far we don't have pairs. What information can we find out given the information that we have? That's the question that you need to know. Can I figure out what side B is? Well, I only have one side. It's not a right angle triangle. I can't use Pythagorean's theorem. I only have one side. I can't figure out what B is just given the information given. I can figure out what angle A is though, because I know that all triangles add up to 180 degrees, which means if I minus both of those, I'm going to end up with angle A. So angle A equals 180 minus 66 minus 55. Or 52, which equals 62 degrees. So now I have one side and one length together. So I know what the ratio is going to be, and I know I can use the sine law now. So if I use the sine law above, these are my A's, length on top, sine of the opposite angle on the bottom, and that's going to be equal to my x's. So I'm trying to find length x, so I put that on the top, and its opposite is sine 52. So now I rearrange that. So I've got to move sine of 52. Lovely. Sorry, glitch in there. So, write it all out again. So I figured out that this angle is 62. I'm trying to find my x. I've got A over sine A equals x over sine x. We move the sine 52 to the other side, making it multiplication instead of division. And we pull out our calculators and make sure we know how to use them. So if we are rounding to 1/10 of a kilometer, we end up where x equals approximately, because we are rounding, 2.23198. It keeps going on, keeps going on, keeps going on, but I want the nearest tenth of a kilometer. So therefore, the canal is 2.2 kilometers long. I'll just write out our sine law at the top for, and we also got this. For our slides later on. All right, so we have solved it. So by using the 52 and the x, and by using the ones across from each other that we had both of, we ended up figuring out very quickly using the sine law. So, example from the textbook, they rewrote it without the picture on it. Did the same thing where they found the angle that way and then followed through with the sine law. So we can also use the sine law to find an unknown angle. So this time we were finding an unknown side. We can also use it to find an unknown angle if we have the opposing side, as well as two that are across from each other. So down here, they're just showing you how you can rearrange the formula. So before I was writing it with A on top and sine on the bottom, or sides on top and angles on the bottom. You can also write it by mixing around the formula. So if we were saying this is true, we can move sine B to this side. Then move sine A to the other side. Being multiplying. And then also then move, I'm running out of room, so I'm going to do it all in one step. What's being multiplied by, then divided by at the same time. So we can move those around. Same as our fractions, the ratio doesn't matter as long as you have both the angles at the top or both the angles at the bottom. The only way you couldn't do it if you were trying to write it like this, that would be wrong. So you got to have both the angles at the top or both the angles at the bottom. Doesn't matter. They are both, you can use it both ways. So this way is easier. So whatever you're trying to find, put it at the top. Because like we said in previous situations, it's much easier to manipulate the formula when what you're trying to find is on the top. Otherwise, you end up with extra steps. So example 2. Find an angle using the sine law. So an acute triangle, TUV, where TU equals 11.1 centimeters, UV equals 5.8 centimeters, and angle T is 31 degrees, find the measurement of angle V to the nearest degree. So we got to get some drawing out, otherwise this is not going to make any sense. So doesn't matter what your triangle looks like, this is just a diagram to help you understand. So we've got T, U, V. Capitals are angles. So TU, put some color in here. TU is 11.1. So TU we can also call little v, not, that looks a little too big. So small v. So TU is also a small v. UV is 5.8. UV is also small t. And angle T is 31 degrees. So like I said, you don't have to draw it so that it looks like 31 degrees. We're just making a diagram so that you understand. So we're trying to find V to the nearest degree. So this is only a one-stepper. We don't know anything about U. We don't care about U. All we need to know is we need to have the information that we need is to have one set that are across from each other that are correct. And we need to know the opposite of what we're trying to find. So that's why we give them the same letter names, so that we understand that they're a set, that they're connected in some way. So now, because we're trying to find an angle, we're going to put the angles on top. Makes it easier. So sine t over t is going to equal sine v over v. So big T is 31 degrees, little t is 5.8 centimeters. Big V is what we're trying to find, and little v is 11.1 centimeters. So now we rearrange our formula. Should really put the v on the other side, but whatever. Step 1, putting it over there, but we're not trying to find what sine v is. Oops, 11.1. We are trying to find what real v is. So 11.1 times sine of 31, and you can do this in little steps as well and figure out what that is. So make sure you are not rounding. You're using at least 4 decimal places at this point, because if you're rounding too much, you're going to end up, actually I should put that on the side, you're going to end up with an incorrect answer at the end. So the more digits you use, the better. So sine to the negative 1 of 11.1 times sine to the 31 divided by 5.8 is our answer. And like I said, you can do that in little bits, or you can do that in one big go. So if you did that in little bits, the part that's in there, sine negative 1 is approximately, and then that keeps going, but at least use at least 4 digits. And then we've got an approximate angle of 80 degrees to the nearest degree. So it would be 80.29 something, 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 but it asked for it to the nearest degree. So there we go. So in words, therefore, angle V is 80 degrees. We always end with a sentence when we're doing a word problem. So we understand, or I understand that you understand what the answer is. So really just a matter of knowing the information. So first drawing your diagram, labeling it correctly, knowing the information you have, and rearranging the formula. There it is, all nice and neat out of the textbook. And example 3 is the perimeter of the Bermuda Triangle. So we just are just outside that. Using the information given in the diagram to determine the perimeter of the Bermuda Triangle to the nearest 100 kilometers. So now we want nearest 100 kilometers. So we got to make sure we're doing that. When I was living on the ship and we were traveling, the day we entered the Bermuda Triangle, my mirror fell and smashed inside my closet. So I have some belief in the magic of the Bermuda Triangle. So what information do we have? Let's angle, or let's draw on this. So I've got an angle M. I need a little m. I don't have an angle for B. I do have an angle for S. I don't know what little s is. Let's see if I can get a color that'll show up on there. There we go, little s, little m. I do have a angle or a number for little b. So here I'm solving for all of them. I've got to find what little s is. I've got to find what little m is. I want the perimeter. So perimeter is the length of the outsides. So I already know one length of an outside. I need to find what s and m is. So I'm going to need all the angles. So I start off with my 180 degrees minus 50 minus 74. And all of that equals 56 degrees. So now I know angle B is 56 degrees. Because I need to have one that is correct across. So one set, one pairing. Since I am finding the lengths, I want the lengths to be on top. So first I'm going to find S. Actually, let's write it out. Little b over sine b. So I still don't know my S. That's what I'm trying to find. So really what you're trying to find, I keep putting what I know first and then what I'm trying to find. It's a little easier if you put what you're trying to find first. So I'm going to leave that on the left-hand side. So my big S is 74. My little b and my big B angle. So now it's just one step to rearrange the formula. I'm solving for S. I need to isolate it. So in order to get rid of that sine of 74, I need to multiply it on both sides or jump it over the equal sign and change its sign. And that's just a matter of calculator work. So you can do it in two separate bits, but don't round them if you're doing it that way. You should be learning how to use the brackets on your calculator so that you can put it in similar to what's going here. So side S is approximately, rounding to the nearest kilometer, 1,855 kilometers. Now I need to do, so that gives me S. Now I'm not going to round yet, even though I want to round to the nearest 100 kilometers. I'm not going to do that till the end. So we don't want to round both of them and then add them together. We don't want to round twice because that could be wrong. I want to make sure that we add them together first. All right, now I need to find M. So again, leaving it on the left-hand side is better. Oops. And again, I'm going to go back to using B because it's more solid, because it was the first one I found out, making sure that I could double check to make sure I didn't make a mistake there. So M is what I need. The angle opposite M is 50 degrees. So again, I need to move across what's underneath the formula, or what's underneath what I want to do. So I have to multiply both sides by sine 50 to get rid of it. On the left-hand side, put all of that into my calculator. And I'm getting 1478 to the nearest kilometer. Now I need to add them up because I want to know the perimeter. And then I'm going to round. No! All right, iPad's not having much fun today. It's wiped out everything. All right, so we had figured out, let's redo the diagram. Little m, 1478. Little s was 1855. And our big B is 56. So in the end, I just want to add them together. And round to the nearest 100. So therefore, therefore the perimeter of the Bermuda Triangle is about 4,900 kilometers. Answer from the book. So to find the last angle, you could do two different ways. One, as long as you've got something that you know all the information from. So if you did M first, they did M first and then showed that you could do it using B, or you could doing it using M. I recommend going back to the one that's more information was given to you, because if you had messed up here, if you'd messed up here finding your M based on your B, then you would mess up both angles. So I'd always go back to the beginning. All right, key concepts. First, labeling. Angles are always in capital letters. What is opposite to them are in lower letters for the sides. In acute, and we're always using acute triangles right now. Acute meaning all of the angles are less than 90 degrees. So we've got smaller triangles. We don't have anything with an obtuse angle, nothing with a big angle. In an acute triangle ABC, the sine law states that A over sine A equals B over sine B equals C over sine C. So those ratios will always be the same. The sine law can be used to find an unknown side of two angles, and can be used if you know. You can find an unknown side if two angles and one side are known. An unknown angle if two sides and an angle of an opposite side are known. The sine law can also be written angles on top, sides on the bottom. So we need to have three pieces of information if we want to find something. So we need to have one complete set and one of the opposite that we're trying to find. That's basically what that's saying. We have one complete side and opposite angle, and then the opposite of whatever we're trying to find. Homework for today.